All right, so we just finished up talking about right triangles. The next shape on the list is quadrilaterals, and polygons in general, quadrilaterals, and on up. So we'll dive into the general sense, into all the polygons first, and then we'll talk about quadrilaterals in a lot more detail. Today we're going to focus on finding the angle measures in polygons. Okay? And you can see some vocabulary terms you're definitely going to want to make sure that you know from this section: diagonal, interior angle, exterior angle, the different types of polygons, and then what a regular polygon is. Okay? So first up, diagonals. A diagonal is a segment that joins two non-consecutive vertices. Non-consecutive meaning, not in order, not one after the other, and we'll talk a little bit about that. And how that pertains to the definition of a diagonal. Interior angles are just the angles on the inside. Obviously, this is the original angles of a polygon. Inside angles, I think we know that. Exterior angles, we did talk about with triangles. Exterior angles form linear pairs with the interior angles, and you create exterior angles by extending sides, right? And again, we talked about those with triangles a little bit, and any polygon is going to have exterior angles. Okay, all right, a couple of theorems here, but before we get to that, I want to talk a little bit about how to come up with the sum of the interior angles, right? And so to do that, let me bring up a sheet here that we can create some shapes with. Okay, we could do a triangle first if we want to, right? But we know that the sum of the interior angle of a triangle is 180 degrees, right? What about a rectangle, right? How do we figure that out? Well, we might remember that it's 360, but even if we don't, what if we drew a diagonal from one of the vertices, right? So from this vertex right here, a diagonal, again, is a segment that joins two non-consecutive vertices. So non-consecutive would mean, consecutive would mean this vertex to this vertex, okay? That's one vertex after the other. Non-consecutive then would go from here to here, right? We skip a vertex and draw to the next one. Okay, well, how does that help? We just created two triangles. We know the sum of the interior angles of triangles are 180, right? Well, since there's two triangles here, then we can find the sum of the interior angles by just taking 180 times 2, or 360, right? What about some other shapes? What about let's see. The next polygon on the list would be a pentagon, right? So what about that guy? We don't know what the sum of the interior angles of that guy are either, what that guy is either, but we can draw the diagonals from one vertex, right? So if I draw the diagonals from here to here, we'll do that a little straighter. And then from here to here, that's a diagonal also, right? Because it goes from one vertex, we skip a vertex. So we start here, we skip this guy and draw to here, right? Well, we've got three triangles. The sum of the interior angles of these triangles, again, are still 180. So we would do 180 times 3, right? And get 540. We can keep going through this, right? Instead of a pentagon, we could do a hexagon. Right? And do the same thing. all the diagonals from one vertex, from here to here, from here to here, and from here to here. Now how many triangles did we create? We created 4. So to find the sum of the interior angles, we take 180 times 4, right, which is going to be 720. So the sum of the interior angles of a hexagon would be 720 degrees. Now hopefully we're starting to see a pattern here that's going to work out every time, right? And that pattern was, for a triangle, we only made one triangle, right? We already had one triangle, so we'd do 180 times 1. For the rectangle, we drew a diagonal and created 2 triangles, so we could do 180 times 2. For the pentagon, we were able to create 3 triangles, and for the hexagon, we were able to create 4 triangles. Okay? Triangle has 3 sides, right? If we talk about the number of sides, rectangle has 4 sides, pentagon has 5 sides, hexagon has 6 sides. Look at the difference here every time. The number of triangles you create is exactly 2 less than the number of sides that a shape has. And when we know the number of triangles that we can create with diagonals, we can just multiply that number times 180, because the sum of the interior angles of a triangle is always 180. So this is going to apply no matter how many sides the polygon has. And so that gets us to our first theorem, okay, which says the sum of the measures of the interior angles of a convex n-gon, okay, n-gon just meaning number of sides, any number-sided polygon, comes from this formula right here, where n is the number of sides, and you see that down here. Okay, like we just saw, we can create 2 fewer triangles than we have sides when we draw the diagonals in. Okay, so it's in other words, the hexagon's got 6 sides. When we draw the diagonals in, we create 6 minus 2, or 4 triangles. So we take 4 times 180 to find the sum of the interior angles. And that's where the 720 came from. Okay? And again, there's a corollary to this theorem that talks about quadrilaterals. You're going to get to know very well that the sum of the interior angles of a quadrilateral is 360. And I can prove that by, again, drawing a diagonal and realizing that we create 2 triangles that we're going to add, so we can take 180 times 2 to find the sum. Okay? So let's apply that. Find the sum of the measures of the interior angles of a convex octagon. Right? Convex octagon. Remember, octagon has 8 sides, right? So I'm going to do n minus 2 times 180, and that will tell me the sum of the angles. All right, octagon's got 8 sides. Right, 8 minus 2 is 6. 6 times 180. Right, and that's going to be 1080. So the sum of the interior angles of an octagon is going to be 1080 degrees. They all have to add up to 1080. Right? Now, we can work backwards too. If we know the sum, then we can find out what kind of polygon it is. Right? That the sum of the measures of the interior angles of a convex polygon is 900 degrees. Classify the polygon by the number of sides. Well, we already know the sum, which is 900. What we need to know is what n is in our formula. So easy enough. However you want to approach it is fine. We can go ahead and divide by 180. Right? And that is going to be 5. And then we add 2 to both sides. And so, oh, sorry, not 7. We're looking at a heptagon. Okay? All right. Piece of cake. Couple examples here for you. The sum of the measures of the interior angles of a convex polygon is 1440. Classify the polygon by the number of sides. And then number 4 here, the coin shown is in the shape of a regular 11gon. Find the sum of the measures of the interior angles. I'm going to give you a second to work these out. So you can stop the video, try it, see what you come up with, and then you can start the video up and make sure that you're right. Okay, so that's what you should have come up with. 10, so a decagon for number 3. And then the sum of the interior angles would have been 1,620 for the regular n-gon. Okay? All right. Got another type of problem here for you. Another way we can use these interior angle sums, right? The measures of 3 of the interior angles of a quadrilateral are 89, 110, and 46. Can we find the fourth? Well, if we know what all 4 of them have to add up to, then we can find the fourth, right? So, if we don't remember that it's 360, we can always do our formula, right? The sum is going to be equal to 4 minus 2 times 180, the 4 because the number of sides is 4. We get 2 times 180, or 360. Now, that means that when we add all 4 angles up, they have to add the 360. Now, we don't know what one of them is, so we'll let it be x. So we're going to add these guys up. 89 plus 110 plus 46. We get 245 degrees. Then we're going to subtract 245 from 360. And we get 115 degrees. So that fourth angle is 115 degrees. Okay? No problem, right? Some more examples here for you. Try these guys and then start the video back up and see how you did. Okay, should have come up with this. The fourth angle on number 6 should be 72 degrees. And the 2 missing angles, which are actually congruent, right? Did you catch that? So if we're going to let one of them be x, we'll let both of them be x. So the missing angles there, S and T, are both going to be 103 degrees. Okay? All right. Moving on. Exterior angles. Really cool thing here that you could do with the shape here that's in your notes. Copy it down on a separate sheet of paper and fill in these sides so that they're straight, right? But then you could name all these angles: angle 1, angle 2, angle 3, angle 4, angle 5. Remember, exterior angles are created by extending a side, and they're always linear pairs with the interior angle that they're next to. Okay? Then you could cut these out. So if you trace this on a separate sheet of paper, number the angles, cut the angles out, right? So you'd cut here, here, and then just kind of cut straight across. And then once you had all 5 of these cut out, put the vertices all together, right? Point the angles so that they're all meeting in the middle, or the vertices are touching. And what you would do, what you would find, is that they would form a circle. Okay? This would happen for any polygon that you did this for. They would always form a circle. What that means is if I add angle 1, angle 2, angle 3, angle 4, angle 5 together, they have to make a circle, and the degree measure of a circle is 360. So since this works for any polygon out there, we have a theorem that says that the exterior angles of a polygon are going to add to 360. Always, 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 always. Okay? Try it at home. I bet you can do it. Create yourself a hexagon. Extend the sides around like this. Number the angles, cut them out, and put them all together. and you'll form a circle. Okay? If we have some time in class, we'll do that next time. All right? But that's your theorem. So any polygon out there, the exterior angles are always going to add to 360. Okay? So, use that. How do we use that? Well, here in number 8, we have an example here where we have the 4 exterior angles of a quadrilateral. Well, we just said that when you add up those exterior angles, they're always going to add to 360. So, just solve simple algebra here, right? So 3x is equal to 504. Then divide by 3. And x is 68. So what's the value of x in this picture? It's 68 degrees. Or it's not, sorry, not degrees, but 68. Okay? Number 9, the convex hexagon has exterior angles with those measures. What's the measure of an exterior angle at the 6th vertex? So we've got 1, 2, 3, 4, 5 here. We know one more exterior angle. We need one more exterior angle for a hexagon. But we also know that they have to add up to 360. So we're just going to add these guys up. Set them equal to 360. Okay, simple enough. Just add up these 5 angles. Forgot the 34 there. Let me get 283. And so we subtract from 360. And x is going to be 77, which you can't really see, but it's there. Okay? All right. Now, regular polygons. Remember regular, what regular means? Regular means all angles congruent, all sides congruent. Right? Well, if we're going to, we can find angle measures in a regular polygon. Okay? This trampoline shown is shaped like a regular dodecagon. Remember what a dodecagon is? It's got 12 sides. Okay? Well, if it's got 12 sides, then you can count them up. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 angles. Okay? If it's regular, all those angles are the same. How would you find the measure of 1? Well, we've got to find out what they have to add up to first. So the sum is going to be n minus 2 times 180. Right? 12 minus 2 is 10 times 180 is 1800. Now, since they're all the same, right? Now, since they're all the same, they have to add to 1800, and they're all the same, then we just take their sum and divide it by the number of angles, which is 12. And that gets us 150 degrees. So each angle is going to be 150 degrees. Same thing for the exterior angles. We know they're going to add to 360.
Well, you're in here.
Okay? And since there's 12 of them, and they're all going to be the same, again, we're going to draw an exterior angle at each vertex. There's 12 exterior angles. They have to add to 360. They're all going to be the same because, again, this is a regular dodecagon. So just divide 360 by 12, and we're going to see that that each exterior angle is going to be 30 degrees, which makes sense because each exterior angle has to be supplementary to their interior angles. So they need to add to 180. Okay? So some uses for the regular polygons as well. All right? That's it as far as the angle measures go. Homework's out in Canvas. Give that a shot. We'll see you guys next time.